Am I the only one that didn't know how crucial shelter was for survival on the war front? Before we dive in, make sure to like, share and subscribe to the channel. And don't forget to hit that notification bell so you never miss a survival secret. If you want to understand real warfront survival, not the Hollywood version, but the kind that decided whether soldiers froze, sickened or lived through winter, you have to stop looking at weapons and start looking at shelter. During both World War I and World War II, cold killed almost as effectively as enemy fire. Entire units were lost not to bullets, but to exposure, damp air, rot, mould, and fuel starvation. Engineers obsessed over heaters, stoves and insulation, yet many winter barracks and bunkers still failed. What's rarely discussed is that when Scandinavian engineers were desperately searching for answers in the 1930s and 1940s, they stumbled onto something much older than modern warfare. They rediscovered how Viking Arctic homes survived centuries of brutal cold with almost no fuel, no machinery, and no sealed walls. The lesson was uncomfortable because it suggested that modern military engineering had overlooked a simpler, more resilient truth. And once that truth was understood, it quietly disappeared from public conversation. Why cold weather warfare failed so often despite modern technology. World War armies entered winter with confidence in coal stoves, metal barracks and tightly sealed shelters. On paper, these designs made sense. In reality, they created lethal problems. Metal structures radiated heat outward at incredible speed. Sealed interiors trapped moisture from breath, cooking and wet clothing. Condensation froze on walls, then thawed, soaking insulation and rotting wood. Mould spread rapidly, causing respiratory illness. Soldiers burned massive amounts of fuel just to stay barely functional. And, when supply lines failed, entire positions became uninhabitable. German troops on the Eastern Front, Allied forces in northern Norway, and Soviet units across the Arctic Circle all documented the same issue. Heat could be produced, but stable warmth could not be maintained. The enemy wasn't temperature alone, it was stagnant air. What Viking Arctic homes understood that modern barracks did not. Centuries before modern physics named it, Viking builders understood passive thermal convection. Their homes were never airtight. They were designed to breathe at a controlled, nearly imperceptible rate. Turf walls were built in layered systems of soil, grass roots, stone, and organic fillers like straw or seaweed. Between these layers were narrow gaps that allowed air to move slowly, not in drafts, but in circulation. So warm air from the central hearth rose upward and outward. Meanwhile, cooler air was drawn in low through the walls themselves, already tempered by that thick insulation. This constant movement, prevented moisture build-up, stabilized the interior temperature and, eliminated mould. Here's something interesting. How World War engineers actually rediscovered this system under pressure. During the late 1930s, Nordic engineers who were tasked with building polar research stations and military shelters revisited those Viking turf structures, and honestly, it was out of necessity. Fuel shortages, supply risks, and remote conditions really demanded shelters that could function with almost nothing. When these airflow-based designs were tested against conventional heated barracks, the results, well, they were pretty unsettling. Turf-inspired structures required dramatically less fuel, stayed dry without mechanical ventilation, and maintained quiet, stable interiors. For soldiers and researchers, this meant fewer illnesses, better sleep, and higher endurance. From a logistical standpoint, it meant fewer resupply missions and reduced dependency on fuel convoys, which were prime wartime targets. Why this knowledge never reached civilian rebuilding after the wars? After World War II, Europe entered an era of mass reconstruction driven by speed, industry, and standardized materials. Concrete, steel, and centralized heating fit economic models far better than labor-intensive, locally sourced designs. Passive airflow systems didn't really align with those emerging energy markets or the new industrial building codes. While Arctic research stations and, some military installations quietly kept elements of these principles, civilian housing actually moved in the opposite direction. Buildings became tighter, more dependent on fuel, and, more vulnerable to system failure. What had proven itself under wartime stress was suddenly labelled impractical for peacetime economies. So, what does this teach us about real survival under wartime conditions? True warfront survival isn't really about overpowering the environment. It's actually about stabilizing it. The Viking-derived approach shows us that warmth, it comes from balance, not brute force heating. Structures that exchange air slowly, they really outperform sealed ones when fuel is scarce. Mass and density matter a lot more than just thin insulation. And honestly, moisture control is every bit as critical as temperature. These lessons applied directly to World War conditions, where, fuel shortages, damp uniforms and overcrowding turned poorly designed shelters into real liabilities. Units that adapted local building knowledge survived longer and operated more effectively than those relying purely on standardized designs. How these principles remain relevant for modern survival thinking. Whether studying wartime history or preparing for long-term resilience, the lesson is clear. Low-tech does not mean low intelligence. Passive systems fail less because they have fewer points of failure. A structure that regulates itself continues working even when supply chains collapse. That truth, mattered on frozen fronts in the 1940s, and it matters now. History keeps showing us that survival favours those who understand environment over those who try to dominate it. Why remembering this matters now? The world wars weren't just fought with tanks and rifles. They were fought against cold, hunger, and exhaustion. Some of the most effective survival solutions weren't invented during the wars at all. They were rediscovered. When ancient knowledge performs better than modern systems under pressure, it challenges assumptions no institution is comfortable questioning. That's why these ideas faded quietly instead of being celebrated loudly. If you found this breakdown valuable, subscribe to Warfront Survival for more deep dives into the overlooked realities of wartime endurance. Share this with fellow history buffs and survival-minded thinkers who care about how people actually lived, endured, and survived when the world was at war.